Yes, friends, I admit, in this video we shall be looking at how to evaluate the integral of functions using the method of trigonometric substitution. So guys, stay tuned, watch the video from start to finish so that you can have every bit of the understanding that is necessary for you to excel in this particular area. Okay guys, let's get started. Let's start with the first general form that we have. When we have it in this form, guys, you notice that how do we recognize that we have to use the trigonometric substitution, particularly guys the sine function? When we have the square root, when we have a square root sign, and friends, what we have at the top is a constant, and we have this difference of squares in which the main variable is the one that is being subtracted. Then guys, when we can express them as squares, it is a good hint for us to use the trigonometric substitution, namely sine theta. Okay, so guys, in this case we are going to let our x to be we are going to let our x, that is the part that is being squared, to be equal to some constant multiplied by the suitable trigonometric function, which in this case is a sine function. But friends, in this case we are going to write it in the form that we want. We are going to have it as the integral of b over the square root of a squared minus something squared, which is what the square root of cx everything squared. Okay, in this case guys, now that we have the difference of squares, we are going to let our what has been squared and subtracted, that is the square root of cx, to be the same as a, which is what has been squared here, sine of theta. If we differentiate both sides, we are going to have square root of c dx to be the same like a cosine of theta d theta. Great. So now guys, at this point now we are going to make the x the subject. We divide all through by square root of c. We have dx to be the same like a cos theta over square root of c d theta. That therefore implies, guys, this our integral then translates now into just the integral of b. It remains the same, square root of a squared minus what is square root of cx, guys? It is simply a sine theta, right? So we are going to replace with a sine theta. What is dx, guys? Dx is what? A cos theta over square root of c d theta. That's what we have it, guys. So in this case, guys, you see that we have an a squared here and an a squared here, right? Because if you square everything, we are going to have an a squared. The a squared, we can factor it out inside the square root, which comes out as a. The a can cancel with this a that we have here. Then we have a b here, and we have a square root of c, which can come outside. We are going to have now b over square root of c integral of, we have cos theta, square root now of 1 minus sine squared theta d theta. But guys, what is 1 minus sine squared theta? It is cos squared theta. Inside the square root gives us cos theta. It cancels at the top, cancels at the bottom. We have just b over square root of c integral of d theta, which, guys, give us just b over c theta. Once you are done integrating, guys, we end with a constant of integration with a constant, namely k. We would have ended up with I always prefer to put c, but since we have used c already, let's use k. Okay, so now guys, in this case now we have integrated, right? But we have it, our answer in terms of theta. We want the answer in terms of x, but let's recall that our cx is equal to a sine theta. If we divide all through by the square root of c, like we are going to have if we divide all through by a, sorry, we have sine theta to be the same like square root of cx over a. To solve for theta now, we are going to take sine inverse on both sides. We are going to have our theta to be the same like sine inverse of square root of c x over a. Means, guys, this our result now simply translates into b over square root of c sine inverse of the square root of cx over a plus a constant of integration k. Okay, that therefore implies, guys, this our integral now can simply just translate into just b over square root of c sine inverse of sine inverse of the square root of c over ax plus k, guys. That is this is the value for this our integral. Okay, now guys, let's take an example when we have real numbers involved. Okay guys, here's the integral. We are going to be looking at the integral of 2 over the square root of 16 minus 3x squared dx. Okay, now guys, we are going to write this integral similarly as we did for this case. We are going to write it as the integral of 2 over the square root of, we can see 16 as 4 squared, right? Minus 3, that's square root of 3 x everything squared. Okay, in this case, guys, similarly we can let our square root of 3x to be the same as 4 sine theta, because 4 is what has been squared, right? Just as we let it to be a sine theta. That therefore implies, guys, if we differentiate, we are going to have the square root of 3 dx to be the same like 4 cos theta d theta. Make dx the subject, we are going to have dx to be the same like 4 cos theta over the square root of 3 d theta. Okay. That therefore implies, guys, this our integral therefore translates into, we have the integral of 2 over square root of 4 squared minus, what is square root of 3x, guys? It is simply 4 sine theta. We have it here. Then dx is what? 4 cos theta over square root of 3 d theta. Now, guys, let's watch. We have 4 squared, we have 4 squared, right? 4 squared can come out as 4. The 4 that we have here can cancel with the 4 that we have. There is a 2 here, and this is square root of 3, which can come out as, we are going to have the 2 over square root of 3 integral of just cos theta over 1 minus sine square theta d theta. What is 1 minus sine square theta, guys? It is simply cos square theta, right? Inside the square root gives us cos theta. It can cancel at the top and cancel at the bottom. We are going to have 2 over square root of 3 integral of theta, which just gives us 2 over square root of 3 times theta plus c. Okay. Now, guys, what is theta? We need to solve for theta because our answer has theta. Meanwhile, we were given this our integral in terms of x. Okay. So in this case, guys, we are going to record that our square root of 3x was 4 sine theta, making dx, if we make sine theta the subject by dividing not 2 by 4, we have sine theta to be seen like the square root of 3 over 4x. That therefore implies, guys, our sine inverse of our theta becomes sine inverse of the square root of 3 over 4x. Okay. This our answer now therefore translates into, we have 2 over the square root of 3 sine inverse of the square root of 3 over 4x plus c equate. So, guys, we are done. That is it, guys. Like the video, guys. Subscribe to the channel if you want to have more great content from us, guys. Please share the video. Like I said, place a comment down below. Let me know what you feel about the video. Have a blessed day, friends.